In this video, we're going to practice approximating the slope of a tangent line. If you want to follow along, the links to the companion worksheet are in the description below. Here we're still using the idea that we're approximating the tangent line slope. So that means we're still approaching this from the point of view of trying to find the slope between 2 points. Now the problem is with a tangent line we're only given 1 point. And the way we approximate it is we choose just one point that is next to, or rather close to, the point that is given to us. So let's get started. Here we have this function, 2x plus 3, and we want to approximate the slope at the point b equals 3. So what we do for this, and you'll see why once we get into some later examples why we do this, is we pick one point slightly to the left of that and one point that's slightly to the right. And then we find two slopes to be sure that they agree. So what I usually do is I usually pick a point that is 0.1 unit either way. So first I'll find f of 3.1, and we will find the slope between 3.1 and 3. And then we will also find the slope between 3 and 2.9. And ideally, we want these two numbers to be relatively the same. So when we calculate this, times 2 plus 3, we get 9.2 minus 9 over 0.1. Here we get 9 minus 8.8 over 0.1. So the difference in both cases is 0.2 over 0.1. And so when we divide, we get slopes of 2. So that is our approximation for the slope of the tangent line. Now fortunately, these two are exactly the same, and that won't always happen, as you'll see in the next one. And so what we would normally do is look for the number that's in between them. So looking here, we have t squared minus t. We want to find the slope approximately at 2. So we find the slope at 2.1 minus f of 2 all over 2.1 minus 2. And then we find the slope at 1.9 minus f of 1.9 all over 2 minus 1.9. So when we plug in 2.1, we get 2.31. Then we plug in 2, we get 2. When we plug in 1.9, we get 1.71. So when we find the difference here, it's 0.31 over 0.1, and here it is 0.29 over 0.1. So here the slope on one side is 3.1, and here the slope on the other side is 2.9. Now again, these are just approximations. Here we're picking one point to the right, one point to the left. But we want to find what's the actual tangent slope, and what it is in between those two. So what we'll say is that it is approximately 3 is our tangent slope. That is our approximation. All right. So on to the next one. Here we have b of 5. So we're going to pick 5.1. That's our point to the right. And we'll pick 4.9. f of 4.9 all over 5 minus 4.9. So when we plug in 5.1, square root of 1 plus 2 times 5.1, that gives us 3.347. And plug in 5, we get 3.317. And then we plug in 4.9, 3.286. So 3.347 minus 3.317 all over 0.1. Here we have 3.317 minus 3.286. 0.286 all over 0.1. So we have 0.03 over 0.1. Here we have 0.031 over 0.1. So when we divide both of these by 0.1, we get 0.3 and 0.31. So the in-between slope between these two is 0.305. And again, we want to find in between these two, and that number is exactly in the middle. So here we have the function 1 over x, and so we plug in negative 1.1 and negative 0.9. So we plug in negative 1.1, 1 all over negative 1.1 minus negative 1, and then negative 1 minus s of negative 0.9 all over negative 1 minus negative 0.9. So we plug in 1.1, and when we get negative 0.91 minus, plug in 1, we get negative 1. Notice here that it is negative 0.1 in our denominator. Negative 1 minus, and here we get negative 1.1 repeating. Here also we have negative 0.1 in our denominator. So when we combine these, this becomes a positive 1. So we have 0.9 over negative 0.1. Here we have 0.1 over negative 0.1. So what we get is negative 0.9 over and negative 1. So our slope is somewhere in between here. So approximately negative 0.95 will be our slope. Now, this works when you have functions that are continuous and as we call differentiable. These two slopes should match. But here on the next set, you're going to find that they're not differentiable. And this is why we always find the slopes from the left and from the right. So if we choose a point to the left of 0.1 and to the right of 0.1, they produce different slopes. So for number 5, let's see that. So here we have f of 1.1 minus f of 1 all over 1.1 minus 1 versus f of 1 minus f of 0.9 all over 1 minus 0.9. Now plugging in 0.9, 1, and 1.1 into absolute value, that's going to give us 0.1 minus 0 over 0.1. This is going to give us 0 minus 0.1 over 0.1. So we end up with 0.1 over 0.1, which is a slope of 1, versus over here we have negative 0.1 over 0.1, which is a slope of negative 1. So these two numbers aren't at all close together. So that means we can't approximate the slope of the tangent line here. These numbers need to be a lot closer than what we see here. So looking at number 6, same idea. So we want to find the slope between 1.1 and 1, and the slope between 1 and 0.9. When we plug in 1.1, we're going to plug that into here for x squared. So that is 1.21 minus, if we plug in 1, that goes up here into x, so that's 1. Here we plug in 1, so that's 1. We plug in 0.9, that is also x. And when we subtract 1, we have 0.21 over 0.1. Here we have 0.1 over 0.1, So this simplifies to 2.1, and this simplifies to 1. So again, here these two slopes look nothing alike. So we can't approximate the tangent slope here. And then finally, here we have this one. And so we want to find the slope between 1.1 and 1. And then 1 and 0.9. Now what's interesting here is if you try and plug in 1.1, this doesn't even work because you get a negative under the radical. And in starting calculus, we don't deal with complex numbers, which means this slope doesn't even exist. So that's a problem for us because we want both of these to be equal. Now for sake of completion, we'll finish this off and find the value of 1. So if we plug in 1, 1 minus 1 is 0. If we plug in 0.9 squared minus 1, we get 0.19 under the radical, so that's 0.43. We'll round that to 0.44 over 0.1, so we get a value of negative 4.4 coming from the negative side. But since the positive side doesn't exist, the tangent line, we can't approximate it. So for these above two, the slope from the left and the right didn't match. And so therefore we can't find the approximate slope. And for number 7, one side didn't even exist. So finally on this last page, all we're doing is we're just writing the expression. Now here, for this first one, here we're using a point that is to the right of 3. So that means it's greater than. So the expression is going to be f of 3.1 minus f of 3 all over 3.1 minus 3. And since we don't know what f of x is, we're just going to leave that expression written just like that. Here, now it says we want to use a second point that is h units away. So unlike this entire exercise where I was using 0.1 units, now we're saying it's h units away. All right, well we can do that. Now it says to the left, that means it's less than, so we're going to subtract h. So we start with g of negative 2, and the next point is negative 2 minus h all over negative 2 minus quantity, negative 2 minus h. And for simplicity's sake, we could simplify this a little bit. G of negative 2 minus g of negative 2 minus h all over. With the negative distributing in, the 2 becomes positive and cancels out the negative 2, and so you're just left with h. So then finally at the bottom, we want to write the expression that is h units to the finding the tangent line slope at A using a second point that's h units to the right. So that means we're going to add h. So h of A, that's our point, but we're going to go h units to the right, so we add that. Subtract, our point is h of A, all over A plus h minus A. So that simplifies to h of A plus h minus h of A all over h. Thanks so much for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and you like this, share this with your students. Or if you're a student and you like it, share it with your classmates. If you have suggestions or problems that you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the only way to understand something is to do it.